So the Kverneland CLC range, then we have two machines within the range. We have the CLC Evo and the CLC Pro. Today we have the CLC Pro, which means we have this is a 3-bar cultivator, 3 rows of tine, so our tines are spread over 3 rows, as opposed to the CLC Evo, which is basically the same machine, but its tines are spread over 2 bars. So with the CLC range of cultivators, then we can work in depth-wise. We can work anywhere from 5 centimetres all the way down to 35, and it's a stubbling cultivator plus deep loosening cultivator down at 35 centimetres. Also with this machine we then have a combination of levelling on the rear. We can either have levelling fingers, levelling tines, or as we have today then the levelling disc assembly, and then a range of packers that then will reconsolidate behind this as well. Also with this range of machines we can either run it with a rear packer or without, so we can take the complete assembly off the back and just run it simply as a 3-bar cultivator. So the Kverneland CLC Pro, the tines are spread over 3 bars. We're 80 centimetres between each bar, so we've got a nice lot of room in between the bars, allowing for trash flow and also for deeper working. On the tine assembly itself, as you can see, it's a bolted assembly, so therefore we can move the tines. In the standard format they are 270mm tine spacing, but there's no reason why we can't move these and adjust those sideways, so it's on a bolted design. Also, with it being a bolted design, there's no additional stress that goes into the frame. There are no welded brackets onto the frame, so literally we just bolt the whole assembly onto the frame, so we can take them in or take them out as required. On the tine itself, there again we have a nice long depth of tine, so we're 87 centimetre underbeam clearance on this machine, which means this tine we can get all the way down to 35 centimetres with this tine, maximum working depth 35 centimetres with this tine, but that still allows a lot of room underneath the frame to allow for heavy amounts of trash in stubble to flow through the machine. So the tine itself is auto reset tine. There again we're using our leaf spring technology, exactly the same system that we've used on our ploughs for many years. So we use the leaf spring assembly in its current format with this number of springs in. We are 670mm kilos of tine pressure to hold that tine in position. As soon as we go over 670 kilograms of pressure, the tine will then kick and release. The spring assembly is in its strongest position at the minute, so as soon as that hits an obstacle and starts to release, it then becomes much easier to move up and out of the way, as opposed to a hydraulic system or a coil spring system, which then increases the pressure. The higher it moves up, the more it increases the pressure. With our system it's the other way around, so it's in its stronger position now. As soon as it releases, it then becomes much easier to allow that obstacle to then move. So on the tine itself is a hollow box section tine, fully heat treated. And also we've also got some movement sideways. So this tine assembly is designed, because of where it's held at the top of the bracket assembly, the tine itself has got the ability to move sideways. So it's got the ability to flex sideways, so there again if it hits an obstacle it can then move sideways without bending and without twisting, because of the heat treatment and because of how we mount the actual tine assembly at the top of the tine holder. Moving down to the bottom of the tine, as you can see on this tine, it's got 2 working angles. So the bottom of the tine assembly itself works at 33 degrees. The further we then come up the tine, it then works at 73 degrees. So we've got 2 tines in one. So our deep loosening effect starts at the bottom of the tine at 33 degrees. As we then move up the tine assembly itself, we then change that from a lifting tine to a mixing tine, which then runs at our 73. So like I said, obviously 2 tines within one, depending on where that's working. Metalwork wise, on the tine, then we have an 80mm as standard. We have an 80mm knock-on system. All of our CLC range of cultivators have our patented knock-on system. So at the minute we're running with our 80mm knock-on point, and the actual point itself is, as I said, obviously knocks on. There are no bolts that hold the point assembly on. We have our holder. Our holder is actually bolted onto the leg itself, and then our knock-on system simply pushes in and knocks in. So as I said, obviously ranging from our working range anywhere from 5 centimetres all the way down to 35 centimetres. So at 35 centimetres we'd be working with our narrower 80mm point. We can then go up, so we start off with our 80mm, we then go to our 150, we then go to our 250 sweep, or even our 320. So depending, as we're coming further up the soil profile and working the surface as opposed to the subsurface, we can then go for any one of our wider point assemblies. What you will see on all of our wear metal, then we have this bulb section. So the idea of this, as the soil flows up the actual holder itself, up the point itself, the soil is then taken up and away from the holder. So our point will wear more than our holder. So what we're doing with this bulb section, we're then protecting the holder from wearing. So the wear ratio is 3 to 4 points to the holder. So every time our point wears, we then don't have to go back around and change our holder as well. Exactly the same on our wider sweeps. One of the criticisms with a wider sweep is the fact that sometimes in very wet conditions you can end up with smearing just under the surface, especially with a wider sweep tine. But with the way this sweep tine has been designed, there are no big flat surfaces. You have a nice sharp edge all the way through, and because of the angle, even when this wears down, we still end up with a nice sharp edge. The only way you get smearing is if you have a very flat blade that then sits onto the ground to physically smear the ground. With any of our wear metal, yes, it's a nice wide sweep, but more importantly, it's always got this, maintains this nice sharp edge to make sure that we don't end up smearing under the surface. So at the back of our CLC Pro, on this machine we have a parallelogram system that sits on the back, which will then include our leveling, whether it's leveling disc or combi disc as we have on this machine, and then obviously our packer arrangement that then sits on the back of this. With this machine it will work equally as well, just as a time machine, just as a basic time machine, where we can simply remove the bars, remove the complete back end, and literally just run through as a very coarse cultivator to allow any water to run through and leave it very coarse and very open. Equally, as a combination cultivator, if you then want to work into stubbles and so on, we can then have our leveling elements and obviously our packer arrangement that sits on the back. With our parallelogram system, the way this system works, the higher the packer comes up, the deeper the tines will go in the ground. So our depth control is done via the pins. Literally just a case of simply removing the pins. We have a scale on the side, so we simply remove the pins, pull the machine into the correct working depth, and we can then replace the pins back in. So on this machine is fitted with what's called a Combi Disc. We have various different running positions for our Combi Disc. So there again, on the disc assembly, at the minute it's running relatively straight. So what we're going to be doing with this, we're going to be cutting some of the clods down, but not doing a great deal of leveling, which we don't need to do in these conditions. But equally, if we needed to do a little bit more leveling, what we can do is just a simple case of rotating the actual disc assembly itself. As we rotate it, we then allow the disc to do more cut and more leveling, so we can be as aggressive or as light as we need to be with this assembly. Equally in here, on what's called our CLC Pro Classic, we can then have a very straightforward, simple banana arm assembly that sits on here with a very simple, straightforward tine assembly, leveling tine that then sits in there. So we can either have leveling tines or leveling disc. When it then comes to depth control, very similar system to the same system as we use on our quali disc, where we have a hydraulic cylinder and a shim arrangement. So there again, what we're then doing, we're powering the cylinder down, sliding our shims in or out, depending on which direction of depth we need to go, and then powering that back up against the slot. So our Kverneland ActiPack roller, this is complete with skids and knives, or can be equipped complete with skids and knives. So the ActiPack roller itself is 580mm diameter. It's what's called a shoulder ring press. So the actual soil is then pressed with the shoulders, allowing a nice corrugation from behind the machine. Also with our ActiPack roller, then we have, as I said, we obviously have our skid and knife assembly. And the idea of this, we can have two different finishes from behind the same packer. So with this bar assembly that runs along the back, we can increase or decrease pressure on this bar assembly, which pushes our skids and knives either into the ground or lifts them out of the ground. At the minute, we're in the mid position, so we've got a minimum amount of pressure on the skid and knife assembly itself. So the skid and knife, it rotates and it comes around the back. So as the soil is pushing against, it's sprung loaded. So as the soil flows through, it's then pushed back down with our skid and knife assembly. I'll just take it out so we can see it a little bit easier. So this is what we talk about when we talk about our skid and knife assembly. It's sprung loaded, it's mounted at the top of the actual bar assembly itself, just bolted in at a single top. It's a sprung loaded steel, so it goes round the actual packer itself and then sits out the back. So more importantly, it's running in between each of our rings. So the idea of this, as and when the soil flows through in between the rings assembly itself, we've then got the skid assembly and the knife, which is then cutting the actual soil itself. So if we end up with clods that are occurring in between our ring assemblies, then our skid and knife is then going to break that down. So the bit that does the work at the bottom, it's bolted on, so it is a wearing part. So as and when the skid and knife assembly wears out, we can unbolt that and we can then replace it, leaving the sprung steel back in position.